And here we go. Oops. We have Richard Monastersky, Earth Science Editor. We find many of them already in an advanced state of evolution. The very first time they appeared, as though they were just planted there, without any evolutionary history. Hello? Needless to say, this appearance of sudden planting has delighted creationists, the only alternative explanation of the sudden appearance of so many complex animal types in the Cambrian era in divine creation. I had to read that twice. You get the sarcasm here. Richard Dawkins. This interval, plus early Cambrian, was the time during which metazoan life, i.e. more than one cell, diversified into nearly all of the major phyla and most of the invertebrate classes and orders subsequently known. Not only do we have nearly all of the major divisions, but we have nearly all of the similar divisions of classes and orders right from the early part of the Cambrian defined, and below the Cambrian, no life forms. So that's when life started, so to speak. So early part of the Cambrian defined by them as the beginning of the major diversification of life. Now, prior to the Cambrian, we have some little green algae and some bacteria. H.S. Ladd, University of California, Davis, put it this way. He said, most paleontologists today give little thought to fossiliferous rocks older than the Cambrian, thus ignoring the most important missing link of all. Indeed, the missing preCambrian record cannot properly be described as a link, for it is in reality about 9/10 of the chain of life, the first 9/10 of everything. And then they presume that there was some stuff underneath there, but they didn't find anything. So I don't know what's going on. The whole problem is, I would say, the Cambrian, underneath the Cambrian, is the surface of the earth like bedrock, upon which the floodwaters wouldn't go beneath. It's all over the country, all over the world, rather. And this guy, his elevation, 9/10 the evolutionary of life, is already in place when you get to the Cambrian. Before that, well, according to the evolutionists, the record is missing. See? So 9/10. Well, what happened to the other 10? That, of course, assumes that there was such. There's no evidence for it. They're both saying what the creationists would predict, that when you start, you have basically all of the kinds. Oh, there you go. John E. Repetsky points out that the oldest land plants now known are from the early Cambrian. Approximately 60 Cambrian spore genera, now on record, represent 6 different groups of vascular plants. John E. Repetsky, U.S. Geological Survey. If you read your textbook, it will tell you that the Cambrian involved only shallow seas all over the world, and that there were no land areas anywhere. But now then, we've got 60 spore genera of land plants. 6 different groups of vascular plants. Where do they grow? Those are plants that have wood. Well, then you've got land somewhere, but they haven't bothered to change the textbooks. Amazing. Furthermore, we notice from Daniel I. Axelrod, UCLA, writing in Science, he says, this report of fish material from upper Cambrian rocks, states of Wyoming, Oklahoma, Washington, Nevada, Idaho, and Arkansas, further extends the record of the vertebrates by approximately 40 million years. They just throw this stuff up, and it's in the textbooks. And this was published in 1978. This has been known a while, yet it is not in the textbooks. The vertebrates are way up in the column. They are very complex organisms. They belong to the same phylum that we do, but we find them in the Cambrian with nearly all of the major phyla. In fact, the reason that most people say nearly all the major phyla is that they don't acknowledge, or perhaps don't know, that the Cambrian also includes the vertebrates, supposedly the highest order that we are part of. Notice the statement by Percy Raymond of Harvard University. He said, it's evident that the oldest Cambrian fauna is diversified and not so simple, perhaps as the evolutionists would hope to find it, instead of being composed chiefly of protozoans. That's the single-celled organism that's supposedly the most simple. It contains no representatives of that phylum, but numerous members of 7 higher groups are present, the fact which shows that the greater part of the major differentiation of animals had already taken place in those ancient times. Over and over and over again, these evolutionists support creationism, but they deny it. Percy Raymond, professor of paleontology, Harvard. Now that quotation is somewhat dated. It was published in '67, but it shows the rarity of the protozoans. We capitalize the B. We have now found them in the Cambrian since then as virtually all of the major phyla. It is ironic that the protozoa are almost missing there in the Cambrian, though they do exist. And so, when we look at the Cambrian, we find hundreds of species of trilobites, well diversified. That is, many different kinds, right from the start. They are extremely complex organisms, well differentiated, head and tail and thorax, very complex respiratory systems, nervous system, and eyes, more complex than our own. This is the most common representative form of life in the Cambrian. That's the beginning of where we find 90%, probably 100% of life forms. Then we have represented in the Cambrian most invertebrate classes and orders, nearly all the major phyla, but almost no protozoa. Then we have land plants, 60 different genera, vascular woody plants. There was no land. It looks like a sudden change and a complex beginning. Stephen Gould points out another characteristic at the beginning of the fossil record when he says, our modern phyla represent designs of great distinctness, yet our diverse world contains nothing in between sponges, corals, insects, snails, sea urchins, and fishes to choose standard representatives of the most prominent phyla. Stephen Gould, Harvard. Instead of the gradual progression continuum that would not leave distinctive kinds, you have represented by the fossil record separate distinct kinds in the beginning, just like we see in the world today. Sudden and complex kinds right from the start. But then we look at the chart that's used to represent the fossil record in our biology textbooks. It's fiction. The chart tells us that we began at the bottom with a single-cell organism and gradually progressed upward, becoming more and more complex as we go through the time. But where did a representation like that come from? It doesn't come from the fossil record. In fact, many evolutionists would acknowledge that. Notice, for example, a statement by Stephen Gould, Harvard, from Natural History. He says, these evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of the fossils. Why is it reasonable then? Wow. Okay, now the point that we make here is not how you infer it, but is the inference even seen as evidence from the fossil record. And Dr. Gould said, nope, it's not there. But where do you get these trees that are in the Cambrian? Compare another quotation from Dr. Patton's notes. You say, I should at least show a photo of the fossil from which each type of organism was derived. I will lay it out online. There is not one such fossil for which one could make a watertight argument. It is easy enough to make up stories of how one form gave rise to another. They're stories, fiction, but such stories are not part of science, are they? For there is no way of putting them to the test. I don't think we shall ever have any access to any form of tree which we can call factual. Colin Patterson, Senior Paleontologist, British Museum of Natural History. Wow. Amazing. So, turning the page on paleontology. We need a little more space on this. So much evidence in favor of creationism. It's remarkable and exciting to me. Paleontology, a study of fossils relative to the origin of life, points to what? You guess, to the worldwide flood, over and over and over again. The flood provides ideal conditions for fossil formation. So we got preliminary evidence. Now, the great deposits of fossils of all kinds, and especially the vast coal and oil beds of the world, have proved exceedingly difficult to explain on the basis of uniformity. And yet these very organic deposits especially the so-called index fossils, which have been looking at in the textbooks, which aren't in reality, have been made the basis for the standard geologic time scale. And this, in turn, has been the pillar of the structure of evolutionary theory. Let's examine what conditions must be present for fossils to form and be preserved. We shall consider the situation by noting the 6 ways listed by Miller, William J. Miller, Introduction to Historical Geology, in his basic textbook on geology and evolution. Let's examine these conditions. Miller says in which fossil remains can be preserved, adding a few comments of our own about each. That's why this author of this the videotapes and notes, accompanying notes, are so educational. Quotation of 6 points from Miller in italics follows William J. Miller, Introduction to Historical Geology. Point 2. Fossils which are the preservation of the entire organism by freezing. Okay, that's how it's done. It is unnecessary to point out that very few, if any, animals are now being fossilized by this process. Yet it is well known that many extinct animals have been preserved in just this way, especially in Siberia. Numerous animals, this is fascinating, numerous animals have been found in preserved whole with flesh and even hair intact. They were hunted down by the natives there, and the meat was able to be eaten. The fact that these cannot be explained is due to freak action, as often suggested, is obvious from the great numbers of bones interred with them in the same strata. Estimates have run as high as 5 million mammoths, whose remains are buried all along the coastline of northern Siberia and into Alaska. Abundant remains of many other animals, only rarely the entire organism, of course, have been found in these northern lands, especially of the rhinoceros, bear, horse, and other mammals. And look at their sizes, much bigger. Fossils, point 3, which are the preservation of just the hard parts of the organism. Note that the soft parts have also been found preserved. This is the most common type of fossil found, especially bones and shells. At first, one would suppose that fossil deposits of shells or bones would be easily formed and that such deposits are commonly being formed now. However, it is very difficult to point to specific present-day deposition areas which are analogous to those found in the rocks. Bones of land animals or of amphibians or even of fishes may occasionally be trapped in some sediment and buried, but this is not the normal or frequent situation. Usually the bones remain on the surface until gradually disintegrated. Never does one find in the present era great graveyards of organisms buried together and waiting fossilization, as would happen in the textbook. But this is exactly the sort of thing that is encountered in fossil deposits in many, many places around the world. It is not easy to imagine any kind of uniform process by which this conglomeration of modern and extinct fishes, birds, reptiles, mammals, insects, and plants could have been piled together and preserved for posterity. Fish, no less than other creatures, do not naturally become entombed like this, but are usually quickly devoured by other fish after dying. Something happened quickly. When a fish dies, its body floats on the surface or sinks to the bottom and is devoured rather quickly, actually in a matter of hours, by other fish. However, the fossil fish found in sedimentary rocks is very often preserved with all its bones intact. Entire shoals of fish over large areas, numbering billions of specimens, are found in a state of agony, but with no mark of scavengers' attack. I. Valesky, the Lichvizi, Earth in Upheaval. M. Brogersma Sanders says, the life of most animals in the sea is terminated by their capture by other animals. Those that die in other ways are sooner or later eaten by scavengers. Let me just take out the glare here. So to repeat, M. Brogersma Sanders says the life of most animals in the sea is terminated by their capture by other animals. Those that die in other ways are sooner or later eaten by scavengers. This is in a treatise